Tickets to a family concert cost $10 for adults and $3 for children. The concert organizers collected a total of $900 from ticket sales. Number 1. In this situation, what is the meaning of each variable in the equation 10a plus 3c equals 900? So we have two variables. We have a and we have c. A is associated with 10. And if we go back to the word problem, $10 is for the adult tickets. So A represents the number of adult tickets sold. C is associated with 3. And if we go back to the word problem, we see that $3 for children's tickets. So C is telling us the number of children's tickets sold. Number 2. If 42 adults were at the concert, how many children attended? To solve this, we substitute 42 in for A. We multiply 10 times 42 and we get 420. Next, we subtract 420 from each side and we get 3c equals 480. And then we divide both sides by 3 and we get c equals 160. And C represents the number of children's tickets. So C equals 160 children's tickets sold. Number 3. If 140 children were at the concert, how many adults attended? So this time, we're going to substitute 140 in for C. So we've got 10A plus 3 times 140 equals 900. We multiply 3 times 140 and we get 420. Now we subtract 420 from both sides and we get 10A equals 480. And last, we divide both sides by 10 and we get 48 adult tickets sold. Number 4, write an equation to represent C as a function of A. Explain what this function tells us about the situation. So we want to take the original equation 10a plus 3c equals 900, and we want a function that solves for c. So first, we're going to subtract 10a from both sides. So we have 3c equals 900 minus 10a. Now to get c by itself, we're going to divide everything through by 3, and we end up with c equals 300 minus 10 over 3a. This function tells us how many children's tickets are sold if we know the number of adult tickets sold. Number 5. Write an equation to represent a as a function of c. Explain what this function tells us about the situation. Again, we start with the original equation, 10a plus 3c equals 900. This time, we want an equation that solves for a. So the first thing we're going to do is subtract 3c from both sides. So we have 10a equals 900 minus 3c. Finally, we want a by itself, so we're going to divide everything by 10. And that gives us a equals 90 minus 3 over 10c. This function tells us how many adult tickets are sold if we know how many children's tickets were sold. A school group has $600 to spend on t-shirts. The group is buying from a store that gives them a $5 discount off the regular price per shirt. N equals 600 divided by P minus 5 gives the number of shirts N that can be purchased at a regular price P. P equals 600 divided by N plus 5 gives the regular price P of a shirt when N shirts are bought. What is N when P is 20? If we want to know what N equals, we're going to use the first equation because they're telling us P. So we're going to use N equals 600 divided by, instead of P, we're going to substitute 20 minus 5. This equals 600 divided by 15, because 20 minus 5 is 15, and 600 divided by 15 equals 40. And N is the number of shirts that are bought. So this is 40 shirts bought. Number 2. What is P when N is 40? Well, now we would use the bottom equation. P equals 600 divided by N, which they're telling us is 40, plus 5. 600 divided by 40 is 15. And 15 plus 5 is 20. And 20 is P, which represents the regular price. So that is a $20 regular price. Number 3. Is one function an inverse of the other? Explain how you know. For something to be an inverse, the input and the output are simply exchanged. And if we look in number 1, our input was 20 for P, and our output was 40 for N. And in number 2, that 40 for N was our input, and 20 for P was our output. So yes, because the input for the first is the output for the second, and the output for the first is the input for the second. This is what makes an inverse function. The input and output are just switched. Functions f and g are inverses, and f of -2 equals 3. Is the point 3, -2 on the graph of f, on the graph of g, or neither? So if we remember function notation, the x is in parentheses and the y is what it equals. So f says that -2 is the x and 3 is the y. So in the point, we're saying 3 is x, and negative 2 is y. So this would not be on the graph of f. But by definition, an inverse swaps the x and y values. So the answer here would be graph of g because the x and y values are swapped. That's what an inverse is. So the negative 2 becomes the y in function g, and the 3 becomes the x in function g. Here are two equations that relate two quantities, P and Q. Select all statements that are true about P and Q. Choice A. Q equals 7P plus 1,999 could represent a function, but P equals Q minus 1,999 divided by 7 could not. If we look at Q, there's no rules that limit the inputs when we are adding or multiplying. So that could be a function. If we look at P, there are no rules about what we could use as an input on the top of a function or a fraction. We would always be dividing by 7 in the denominator, so this could also be a function. So the correct choice between A, that says Q can be a function but P cannot, B, which says each of them could represent a function, and C, which states P could represent a function but Q could not, B is the choice that is correct. Neither of these violate any rules when it comes to functions. Then if we look at D, the two equations represent two functions that are inverses of one another. And choice E, if Q equals 7P plus 1,999 represents a function, then the inverse function can be defined by P equals 7Q minus 1,999. So if we look at Q here at the top, if I wanted to find the inverse of Q, the first thing I would do is subtract 1,999 from both sides. This would give me 7P equals Q minus 1,999. But now to get P by itself, I would divide both sides by 7, and I would end up with what we have here on the right. P equals Q minus 1,999 divided by 7. So that means the two equations are inverses of each other. So the correct choices are B and D. Crickets make chirping sounds by rubbing their wings together. The number of chirps they make is closely related to the temperature of their environment. When the temperature is between 55 and 100 degrees Fahrenheit, we can tell the temperature by counting the number of chirps. A formula that is commonly used to find the temperature in degrees Fahrenheit is: first count the number of chirps in 14 seconds, then add 40 to get the temperature. Let N be the number of chirps that crickets make in 14 seconds, and F be the temperature in degrees Fahrenheit. What is the temperature when a cricket chirps 52 times in 14 seconds? So the first step was to count the number of chirps. They told us that was 52 times. Then they said add 40 to get the temperature. So we take 52, we add 40, and we get 92. And that 92 represents degrees Fahrenheit. Number 2, write an equation that defines F as a function of N. So we want F equals, N would be the number of chirps, plus 40. Number 3, how many chirps would we expect to hear in 14 seconds when it's 60 degrees Fahrenheit? So now we could substitute 60 in for F, and we said that equals N plus 40. Now we would subtract 40 from both sides, and we get N equals 20. And N represents the number of chirps. So 20 chirps in 14 seconds. And number 4, write an equation that defines N as a function of F. To do this, we would take the original equation, subtract 40 from both sides, and get an equation that says N equals F minus 40. So now we have the inverse. The table shows the value of a car in thousands of dollars each year after it was purchased. Plot the data values and find a line that fits the data. So in this table, the first column is going to be our X, the second column is going to be our y. So we have a y-intercept at 0, 30, then a point at 1, 22.5, a point at 2, 19, a point at 3, 16, a point at 4, 13.5, and a point at 5, 11.4. And then they want us to find a line that fits. So that would be a line somewhere right in here. You just want it to fit as closely as possible. Number 2, write an equation for the linear function c that gives the value of the car in thousands of dollars when its age is t. So we could do this in slope-intercept form. We know we're calling this function c. That equals our slope. And if we look at the line, we could take a point at 20 and then another good point at maybe we say we cross at 19 and 17. So that would be 19 minus 17 as we go from 2 to 3. So we're saying our second point was at 317 and our first point was at 219. This gives us a slope of negative 2 over 1, which is negative 2. And our input is t. And then if we look at the line, the y-intercept appears to be approximately 26. So c equals negative 2t plus 26 appears to be a slope-intercept equation that gives us that line of best fit that we came up with. Number 3, what does c of 6 mean in this situation, and what is the value of c of 6? Well, 6 is in parentheses, so that is our input. And our input is the vehicle age in years. So C of 6 tells us the cost or the value of a 6-year-old car. And according to our equation, C equals negative 2 times 6 plus 26. Negative 2 times 6 is negative 12. And negative 12 plus 26 equals 14. And this is thousands of dollars, so that's $14,000. Number 4. In this situation, what does the solution to the equation C of t equals 2 tell us? Well, the function C gives us the value of the car in thousands of dollars. So this tells us a car of t years equals $2,000. So now we're going to say 2 equals negative 2t plus 26. We're going to subtract 26 from both sides. 2 minus 26 is negative 24. And to get t by itself, we're going to divide both sides by negative 2. Negative 24 divided by negative 2 equals 12. So t equals 12 years old. Number 5. Write an equation that would allow us to find the age of the car when we know C of t. So now we take the original equation, C of t equals negative 2t plus 26. The first thing we would do is subtract 26 from both sides. So we have C of t minus 26 equals negative 2t. And then we would divide both sides by negative 2. So we end up with t equals C of t minus 26 divided by negative 2. Now we have the inverse function. Number 6. Use your equation to estimate the vehicle age when the value of the car will be $500. So we say t equals, because C is measured in thousands of dollars, $500 would be represented as 0.5. Then we subtract 26 and we divide by negative 2. 0.5 minus 26 is negative 25.5, and we divide that by -2. A negative divided by a negative is a positive, and 25.5 divided by 2 is 12.75. And T represents years old. So a 12.75-year-old car would be worth approximately $500. The distance d in kilometers that a car travels at a speed of 80 kilometers per hour for t hours is given by the equation d equals 80t. If the car has gone 120 kilometers, how long has it been traveling? So we substitute the 120 kilometers in for d, and that equals 80t. So to get t by itself, we would need to divide both sides by 80. So we get t equals 120 divided by 80, which equals 1.5. And that time is representing hours. So 1.5 hours. Number 2, rewrite the equation to represent time, t, as a function of distance, d. We start with the original equation, d equals 80t. We divide both sides by 80, and we get t equals d divided by 80. Now, instead of an equation that solves for distance using time as the input, we now have an equation that solves for time with distance as the input. They're inverse functions. Match each function to its inverse. So if we look at A, the first thing we would do is add 3 to both sides. And we would have 2x equals y plus 3. Now we would have to divide both sides by 2, and we get x equals y plus 3 divided by 2, which means A matches choice number 2. B, we have y equals 3x. We would divide both sides by 3 and get x equals y divided by 3, which matches choice 5. C. We have y equals 3x minus 2. We add 2 to each side, and we get 3x equals y plus 2. Then we divide each side by 3, and we end up with x equals y plus 2 over 3, which means C matches choice number 1. D. We have y equals x minus 2. We add 2 to each side, and we get x equals y plus 2, and D matches number 4. E. Y equals x plus 2. We would subtract 2 from both sides and get x equals y minus 2, which matches choice 6. And finally, y equals x minus 2 over 3. We would multiply both sides by 3 and get 3y equals x minus 2. Then we would add 2 to both sides, and we would get x equals 3y plus 2, meaning F matches choice 3. This is how you find inverse functions. Functions h and j are inverses. When x is negative 10, the value of h of x is 7, or h of negative 10 equals 7. What is the value of j of 7? If h and j are inverses, then their x and y values are opposites. So, in function h, x equals negative 10 and y equals 7. That means in j, x equals 7 and y equals negative 10. So the value of j of 7 equals negative 10. Determine if each point is on the graph of h, on the graph of j, or neither. Explain your reasoning. A is negative 10, 7. That matches h because x equals negative 10 and y equals 7. So the A is on graph of h because the input is -10, and the output is 7. For b, x is 7 and y is -10, and that matches what we said function j was. So this one would be graph of j because the input is 7 and the output is -10. And our last problem on these practice sets. Here are rules that define function f. F of x equals 2 when x is between -5 included and 1 included. It equals x when x is between 1 not included and 5 not included. And it equals 7 when between x equals 5 included and 7 also included. They want us to draw the graph of f. So, -5 included means I go to -5. I'm going to go up to 2. And because it's less than or equal to, this is included and will be a solid point. This is going to continue equaling 2 until I get to x equals 1. And because it's less than or equal to, this point is also solid. And then I draw the line that connects them. That is the top rule. The middle rule says that between x equals 1 not included and x equals 5 not included, the value is x. So I want a hollow point at x equals 1 when y equals 1. I want a hollow point at x equals 5, y equals 5, because that is not included. And then I want the line that connects them. That shows the middle rule. And finally, when x equals 5, the function equals 7. And we use a solid point because it says less than or equal to, so it's included. Then I go to x equals 7, y equals 7. Because it says less than or equal to, that point is also included, and I draw the line connecting them. And this is the graph of the piecewise function f. If it says less than or equal to or greater than or equal to, then it is included and it has a solid point. If it says only less than or only greater than, then that point is not included and we have a hollow point at that location. If you have any questions about inverse functions, piecewise functions, or any of the problems on these worksheets, Please use class time to get clarification before our next test, which is scheduled to be Monday, February 12th.